Alright, CNT120, we're working on Chapter 4, and we're now looking at the TCP protocol. So I'm reminding you here, TCP, we're looking at the transport layer of OSI model as well as the TCP IP model. Okay? If you remember back, that's the layer responsible for reliable data transport, if you want to think of it that way. Provides reliable data delivery. Look at that. I got ahead of myself there again. Okay, so I'm going to remind you that there are certain protocols, upper layer applications, upper layer protocols that use TCP for reliable data transport. This is not something we choose. This is not something we pick. This is not something we select. It just does that for us. And if I look, I grabbed this graphic just to show you. Here are a handful of protocols that use TCP at layer 4 for reliable data transport. And if I start taking a look down through, things like Telnet and SSH use TCP, a whole bunch of different types of file transport, FTP, secure FTP, secure copy, all use TCP. My email applications, Simple Mail Transfer Protocol, POP3, IMAP4, all use TCP. My web browsing, HTTP, uses it, and so forth. This is even a routing protocol. They all use this for reliable data transport. They use TCP. Okay? That's not something we choose. It's something that happens all for us. Okay? They need the reliable data transfer. And as I like to say it, if I transfer a large file, like a large, research paper I write, it does me no good to get 2 of the 12 pages. So if I'm going to transfer a file or send an email, I need the whole thing for it to be readable, usable. That's why TCP is getting used for that. Okay? So just trying to put it in perspective for you what's using TCP. While 3 main characteristics of TCP are that it is connection oriented, it uses sequencing and checksums, and uses flow control. Well, let's take a look. Connection oriented is before any data is actually sent, it communicates with the other end to establish a session. So before it transfers anything, it calls the other end, so to speak. It says, hey, I'm going to send data. Are you ready? And the other end says, yeah, go ahead. Okay, here we go. And it's one of those making sure that they're home, making sure your friend is home before you drop off a bucket of frozen ice cream. Okay? You don't want to leave it sitting on the front step. This is your connection-oriented process. This is what TCP is doing. And it does it through a 3-way handshake. We'll get to that in a minute. It also uses sequencing and checksums. So once it starts sending data, it actually uses a sequence number. So it's going to number all the chunks of data. That way we know, the other end knows that it got all the pieces. And it also knows how to put them back in order so that the email is readable and the sentences aren't out of whack and sound like Yoda. Okay? So it's going to use sequence numbers so that it numbers everything, sends it all. The other end can put it all back in order and make sure it has it all. It's also going to use what's called a checksum. You can think of a checksum as a very basic error check. It's going to do a little kind of like a little math computation on it before it leaves, and the other end's going to do the same computation. And if it comes up with the same number, both ends come up with the same number, then they know, okay, the data should be good. The integrity should be there. So it's doing that to make sure it gets all the pieces and to make sure that the data is not corrupted or lost in any way. It's also going to use flow control. Flow control is a way to make sure you don't overwhelm the recipient. So the recipient can say, hey, I'm kind of busy. Don't send me too much at a time. Or the other end can say, hey, I'm not busy. Bring it on. Let's get it done quicker. So flow control is a way to adjust how much data you're sending per time. Sometimes you'll even call it sliding windows. And again, that's there to make sure the other end does not get overwhelmed. They remind us that a TCP segment is actually the upper layer data plus a TCP header. So the upper layer data of like the HTTP request now adds a TCP header, and then now becomes our TCP segment. So here would be the upper layer HTTP data, and now here's the TCP header. All these fields are the TCP header to control the sending and receiving of data, reliable data. So source port, kind of like if it's a web request from my browser, destination port would be the port of the web server, port 80. Sequence number, it's numbering everything. It's numbering all these chunks of data so we know we got them all. Acknowledge that there's to indicate from the other end, yes, I got it. Go ahead and send me more. There's a bunch of flag fields in here to indicate, yes, I got it. No, go ahead and send more. I'm done. Okay, these flags have purposes to kind of indicate, yes, I'm done, or send me more. There's my window size, so we know how much data we're sending per time. There's the little error check. There is a couple other fields in here, and then we actually have our data. This is the upper layer data. The book goes through your header fields. Make sure you're able to recognize these and kind of match them up. Source port, the source TCP port, destination port, the port of the application on the node you're sending to. Sequence number identifies the, kind of that chunk of data so it can get it back in order. Acknowledgement number is going to confirm, hey, I got that chunk of data, send me more, and so forth. Okay, make sure you're able to match these up. Now, the three-way handshake, this is critical for the reliable transport of data. It's actually going to send 3 chunks of data and get everything set up and organized before we send the real data, if you will, the real, HTTP web page, if you will. So here's what it looks like. This computer here, let's say my laptop, is going to talk to the web server and say, hey, I would like to get a web page from you. So it's going to send a chunk of data with a sequence number. Now this is my computer numbering all the bytes leaving my computer. So I like to think of it almost like my odometer, my byte counter, if you will. It's going to label that and say, okay, this is byte number blah that I'm sending, and it's going to leave the acknowledgement in 0 for now, and it's going to flag the server saying, hey, I'd like to synchronize with you. I'd like to synchronize that we can send data reliably, please. So the server will get this, and the server is now going to respond. The server is going to respond with its own sequence number because it has its own byte counter. So it says, okay, this is the first byte I'm sending you, blah, 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 669. It'll then acknowledge my data right here. It'll acknowledge the data I sent. And if you look at the number very carefully, 13558, 13559, that is very, very tricky, or I should say very simplistic but neat. With that number 559, it acknowledges that it received my 558 byte and it's ready for my 559 byte, which is key. That's pretty awesome. It's called an expectational acknowledgement. So that number right there acknowledges that it got 558 and it's ready for 559, the next byte. It also is going to say, okay, I acknowledge your synchronization, and by the way, I want to synchronize with you too. I want to get our sequence numbers all lined up that we know how things are being numbered. So it sends the second handshake back to me, and then I'm going to get it and send the third handshake back to the server. So now I say, okay, I'm going to send sequence number 559. I sent 558 before. Now I'm going to send 559. That's my next chunk of data, next byte I'm going to send. I'm also going to acknowledge the server. The server sent me 669, so we're going to acknowledge with 670, meaning I got 669 and I'm ready for byte 670. And I'm also going to acknowledge its synchronization. I'm going to acknowledge its synchronization. So my three-way handshake, I send a synchronization to the server. It acknowledges that, sends its own synchronization back to me, and then I acknowledge that. And now we both know, the server knows my byte counter numbers, and now I know the server's byte counter numbers, and we are ready to start sending data, labeling everything, numbering everything, and if anything goes astray, I can now refer to it by number, saying, hey, I'm missing byte number, it sent me, 670, I'm missing byte 680. Somehow 680 went missing. Can you resend that? That's the purpose behind this three-way handshake. Okay, it's very, very simplistic, but it's pretty slick. Here is an actual TCP header showing all these fields that we looked at: source port, destination port, sequence number, large numbers, acknowledgement number. Here's the flags field. In this case, this is acknowledgement and a synchronization, so this would be a second handshake if you were looking at it. Here's your window size down here, meaning we can send 5,840 bytes at a time. And then here's a checksum down here. Little mini error check. Hey, everything looks okay. So there's a typical TCP header. Here is the book kind of translates that TCP header for you. Okay. Well, let's take a look at a real TCP three-way handshake and a real TCP header. What I'm going to do is I have my Wireshark open. I'm going to start this here in just a minute. I'm going to open my browser, and I'm going to open a new tab, and I'm going to get ready here. I have everything ready. So I'm going to go over and I'm going to start my Wireshark. So I'm going to open up Ethernet 3, start my Wireshark, start capturing. I'm going to go here and I'm going to go to a website I have not been to before, IMSA.com. There we go. It just loaded. I'm going to go back to Wireshark and I'm going to stop. Okay. I needed to load a web page I have not been to before, so it was not saved in memory. That's the idea behind that. Okay. In my Wireshark now, I'm going to open up my windows here a little bit so we can see a little bit better. I'm going to squish this one down. I'm going to open this up a little bit. And I'm going to try to find my three-way handshake. So I'm going to start off first by doing a search for DNS. DNS happens so I can learn the IP address. Once I learn the IP address, then I can talk to the web server. So I'm going to look for DNS, and I'm going to look for the info field over here. I'm going to look for me trying to talk to IMSA.com. And there's me actually trying to find out IMSA.com. And I'll see if there's any other ones in here. It doesn't look like it, so I'm just going to follow that one. Okay, I'm going to say, hey, I want to find IMSA.com. So I'm going to follow this UDP stream for right now. And here's me talking to the DNS server trying to learn the address for IMSA.com. Here's the query. Hey, what's the address for IMSA.com? And here's the response coming back. Hey, here's the address of IMSA.com of 2314 blah, blah, blah. Cool. So I learned the IP address of IMSA.com. Here is the packet that I've captured, 3266. I'm going to clear my stream. And I'm back here on 3266, and I'm going to look for me talking to this 23 blah, 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 blah. And here actually is a chunk of data of me talking to that 23. Here's the 2314 blah, blah, blah. Here is me talking to 2314 blah, blah, blah. All right, so I'm going to right-click on top of that. I'm going to go follow TCP stream. I want to see me talking to that web server. Okay, so here's 172, me talking to 2314. Cool. I'm now going to look at these first three TCP packets that I've captured. And if I look very closely, what I end up seeing is synchronization, acknowledgement. There's my three-way handshake. Well, let's look at them a little closer. I'm going to open this middle window so I can see the headers better. Ethernet header, IP header, TCP header. Let's look at the first handshake up here. I'm going to open the flags field. This is me, my browser, talking to 443. That is HTTPS on the server. Here's my acknowledgement or my synchronization bit sent. Me trying to synchronize with the server. The second TCP segment, here it is. Source port 443 web server to my browser 1903. It has acknowledged my synchronization and it's set its own synchronization. And if I start looking closer, I start seeing the acknowledgement sequence numbers up here too. Okay, here's the third handshake, me talking to the server again. Source 1903, my browser, server 443. And here's the acknowledgement flag set, acknowledging what they sent me and ready to go. Down here's even my window size of 258. Okay, kind of busy, don't send a whole lot, blah, blah, blah. So there is my three-way handshake talking to my web server. Every time I'm going to talk to something like a web server or send a file, this is going to happen first. This three-way handshake is going to happen first. That is your three-way handshake. Okay? When I come back, I'm going to start talking UDP with you, and you actually will end up revisiting that Wireshark capture.